Hi, this is Mrs. Often, and I'm here to talk about rotations in the plane. This second video will focus on rotations in the coordinate plane, where the origin is not the center of rotation. We will still be looking at rotations of 90 degrees, 270 degrees, and 180 degrees, both clockwise and counterclockwise. To perform these, we will use vectors. Again, we can perform this with rules or visually. It is much easier to think about it in terms of rules of rotating vectors if you first go through the visual process. So you want to be able to think back on the visuals that will help you. Rotation about a point, HK 90 degrees clockwise or 270 degrees counterclockwise, would look like this. You'll notice that this point is located not at the origin, but instead at the point 9, 2. I'll draw a vector from A to the center of rotation. From the center of rotation to A, and I'll note that this vector in its component form can be labeled as -3, 3. To rotate the vector, I will follow the rules for rotating 90 degrees about the origin, but instead I'll use the vector. So now I'll get this other vector, three, 3. This will map to the point A prime. A prime is now along the vector 3, 3 from initial point 9, 2. So the new terminal point will be A prime, and that will be located at 12, 5. So A moves from 6, 5 to 12, 5. We can do something similar with the other vertices. So for Q, I will have -4, 8. And then I will have 8, 4 for my new vector. Moving along the vector 8, 4 from the initial point of 9, 2 brings me to a new point, Q prime, which will be at 17, 6. So through this method, you can rotate about the point 9, 2, or about any point in the coordinate plane 90 degrees clockwise or 270 degrees counterclockwise. A quick summary of this rules is shown here. Draw a vector from the center of rotation to each vertex. Write the vectors in component form. Use the rules shown to rotate the vectors. We trade the coordinates and change the new y coordinate to its opposite. Then graph the new vectors and use them to plot the vertices of the transformed figure. To rotate about the point HK that is 180 degrees clockwise or counterclockwise, we're going to do a similar process using vectors and using the rules of rotation of 180 degrees about the origin, but now with the vectors. So once again, I begin by drawing my vectors to my different vertices. My first vector from 9, 2 to A is -3, 3. My vector to Q is -4, 8. And then my vector to B is -6, 3. I then rotate these vectors using the rule for 180-degree rotation, and I redraw them in the coordinate plane. Here's my vector from the center of rotation to the point A prime, and that's going to go 3, -3. You'll notice that both signs have changed. From the center of rotation to Q prime will be 4, -8. And from the center of rotation to B prime will be 6, -3. By plotting and connecting these vertices, I obtain the rotated figure A prime, B prime, Q prime. Let's review this through the notes below. We draw the vector from the center of rotation to each vertex. We write the vectors in component form, and we use the rules shown to rotate the vectors. The X and Y components stay in the same order, but they are switched to the opposite sign. We graph these new vectors and use them to plot the vertices of the transformed figure. Finally, we'll rotate 270 degrees clockwise or 90 degrees counterclockwise about our center here at 10, 2. So our center of rotation has changed slightly. Our points A, B, and Q have remained in their same locations. So starting from our center of rotation, drawing my vector to A, I'm going -4, 3. So following my rules of rotation from this vector, I would take the coordinates, I would flip them, and I would change the sign of the X component, the new X component. I would therefore get the vector -3, -4. And following that, from my center of rotation at 10, 2, I would arrive at the new A prime point of 7, -2. I would then repeat this process for points Q and B. So to point Q, I'm traveling -5, +8. So to get to point Q, I'm going to be traveling -8, -5 along the vector from the center of the rotation. And that's going to bring me to the point 2, -3. Finally, I'll go from the center of rotation and I'll draw my vector to B. And that is going to be a vector of -7, 3. So my vector to B prime will be -3, -7. And traveling from the center of rotation, -3, -7, brings me to the point 7, -5 for B prime. So given all of that, let's review this verbally. Our rules for transformation: to draw a vector from the center of rotation to each vertex on the original figure, write those vectors in component form, rotate them according to the rules for 270-degree rotation about the origin, changing the order of the components, and changing the new X component to its opposite, graph the new vectors, and use them to plot the vertices of the transformed figure. I hope this has been helpful to you in graphing rotations about any point using vectors.